Ionization energy. In Chapter 2, you were introduced to the term of ionization energy. First, ionization energy is defined as the minimum energy required to remove 1 mole of electron from 1 mole of gaseous atom. X in gaseous state removes 1 electron to become X plus ion. Also in a gaseous state, the energy involved in this process is called as first ionization energy. For the second ionization energy is the energy required to remove 1 mole of electron from 1 mole of gaseous unipositive ion. The X plus ion in the gaseous state removes 1 electron to become X2 plus. Also in the gaseous state, the energy required for this process is called as second ionization energy. Please take note that the more difficult the electrons to be removed means that the more energy will be required for the process involved, means the higher the ionization energy. There are two factors affecting the ionization energy: effective nuclear charge or ZEF, and also the shielding effect. For effective nuclear charge, as the proton number increases, the effective nuclear charge also increases. The size of the atom becomes smaller as the attraction between the nucleus and the outermost electrons becomes stronger. More energy is required to remove the electrons. Therefore, the ionization energy will be higher. For shielding effect, as the number of shells filled by electrons n increases, the shielding effect also increases. The size of the atoms becomes larger as the attraction between the nucleus and the outermost electron become weaker. Less energy required to remove the electrons. Therefore, the ionization energy decreases. Now we look at the trend in the first ionization energy down the group and across the period. Down the group, as the number of shells filled by electrons n increases, the shielding effect also increases. The attraction between the nucleus and the outermost electrons become weaker. Therefore, the size increases. Less energy required to remove the electrons. Therefore, the ionization energy decreases down the group. For example, elements in group 1 and group 2. Here is the trend in the first ionization energy for elements down group 1. Across the period, as the proton number increases, the effective nuclear charge also increases. Stronger attraction between the nucleus and the outermost electrons. Therefore, the size of the atoms decreases. More energy required to remove the electrons. Therefore, ionization energy increases across the period. This is the trend in the first ionization energy for elements across period 2. Although the general trend in periodic table is for the first ionization energy to increase across the period from left to right, some irregularities do exist. From this graph, we can see that Beryllium, with a proton number of 4, has a higher first ionization energy than that of boron. The same thing happened between nitrogen atom and oxygen atom, in which nitrogen atom with a proton number of 7 has a higher first ionization energy than that of oxygen. In period 2, beryllium is found to have a higher first ionization energy than boron, while in period 3, magnesium is found to have a higher first ionization energy than aluminium. This irregularity can be explained by the stability of the completely filled orbital. Beryllium, with a proton number of 4, has electronic configuration of 1s2 and 2s2, and boron, with a proton number of 5, has electronic configuration of 1s2, 2s2, and 2p1. The removal of the first electron of beryllium comes from a completely filled 2s orbital, which is more stable, while the removal of the first electron of boron comes from the partially filled 2p orbital, which is less stable. More energy is required to remove the first electron in beryllium. The same reason why magnesium has a higher first ionization energy than aluminium. In period 2, nitrogen is found to have a higher first ionization energy than oxygen, while in period 3, phosphorus is found to have a higher first ionization energy than sulfur. This irregularity can be explained by the stability of the half-filled orbital. Nitrogen, with a proton number of 7, and has electronic configuration of 1s2, 2s2, and 2p3, while for the oxygen with the proton number of 8 has electronic configuration of 1s2, 2s2, and 2p4. Removal of the first electron of nitrogen comes from a half-filled 2p orbital, while removal of the first electron of oxygen comes from the partially filled 2p orbital. The half-filled orbital is more stable than partially filled orbital, therefore, removal of electron requires more energy. The same reason why phosphorus has a higher first ionization energy than sulfur.